Good day, everyone. We'll now be having your discussion of exercise number 3, estimation of the population mean, population proportion, and sample size calculation for estimation of proportion. So we have situation A, which is about a hospital administrator wanting to estimate the average time of patients in the emergency room. The said administrator in this study recruited 62 patients and determined the waiting time of each individual. An average waiting time was then computed, which was 22 minutes. Now, to also arrive with estimates, he also determined through previous literature the variable that has a variance of 49 minutes. Okay. So the first question in this situation would be, what is the parameter being estimated? Now, these are your four choices, and of course the answer would be A, average waiting time of patients in the ER. Remember, when you're asked what is the parameter being estimated, the parameter that should be estimated should be in that statement in the first place. So whether it is in an average or a mean or a proportion, it should be in that statement. Answering letter B would be, of course, an error since that does not have any parameter at all. Number of patients in the ER refers to the wrong variable. And, of course, D is not viable because we have an answer, which is A. Now, we have question number 2, which is the formula to be able to compute the interval estimate of the parameter. Now, as I have taught you before, the algorithm here would be, first is to assess whether you need statistical inference in order to solve the problem. Next would be to determine what type of statistical inference you would be needing in order to solve the problem. In this case, we do need statistical inference, and then the type of statistical inference that we'll be applying is estimation. Now, the next thing in the algorithm would be asking yourself, what is the parameter being estimated, which we have answered in number 1. We're concerned with a mean rather than a proportion. Now, for a mean, there is an extra question that we need to answer. Is the population variance known, or is the population variance unknown? In this case, the population variance is known. So we'll be using the formula x bar, which is a sample mean, positive, negative, z deviate, which depends on your confidence level or level of significance, multiplied by the standard error, which has a formula of sigma over square root of n. And that would be it for number 2. Now, for number 3, we are asked, what is the lower limit of the 90% confidence interval estimate of the parameter? So, this is just merely substituting all the values of your formula, substituting all the values of the components of your formula in your calculator, and being able to do it properly. So remember that for a 90% confidence interval estimate, the corresponding z-deviate is a 1.64. So you should have used that z-deviate. And you should have properly identified what the sample mean is, which if we go back to, we would know is 22. And the standard deviation would be 7. Remember, what was given was the variance, so you still need to get the square root of it. Now, substituting all of those values, doing it properly inside your calculator, you should be able to arrive with B 20.54. Okay. Now we are asked what the upper limit is. The upper limit, which is still 90%, would be, in this case, C, 23.46. And that's just using the same formula. Of course, you would be using the negative formula for the lower limit, and you would be using the positive formula for the upper limit. Just don't forget that. We have the fifth one, which is, which of the following is a simplified interpretation of the 90% confidence interval for situation A? So, of course, we have taught you this. The components of a good interpretation of a confidence interval estimate would be that, first, the confidence level should be there, whether it's a 90, 95, or 99. Next, the parameter being estimated should be mentioned inside and not just the variable of interest. So, for example, here we have letter A. It says there waiting time of patients in the ER. That does not include the that does not include the parameter being estimated. So it should not be your answer. And then the last component of an interpretation would be, of course, including the lower limit and the upper limit of your interval estimates. And in this case, for this question, the correct answer would be letter B. We are 90% confident that the mean waiting time of patients in the ER is between this and that. That would be the correct interpretation. It has a confidence level, it has your parameter being estimated, and it has your lower limit and your upper limit. Okay. Now we go with situation B, We have an MHO who aims to estimate the proportion of women who use oral contraceptives in Palamigan. To answer his objective, he conducted a survey and randomly selected women who consulted the barangay health centers in his municipality. The result of the survey showed that 308 out of the 400 women included in the survey use oral contraceptives. The first question under this situation is, what is the value of the point estimate of the parameter? Now, you would remember that the point estimates for both of the parameters that we have, which is mean and proportion, are its sample counterparts. In other words, the estimate for the population mean is the sample mean, and the point estimate for the population proportion is the sample proportion. So here, you just merely need to be able to identify the proportion inside the problem, which is 308 out of 400, which gives you 0.77 or 77%. And that is B inside this question. Next, what is the formula to be able to compute for the 95% confidence interval estimate of the parameter? So here we are asked to use a 95% confidence level, and the parameter that we are estimating is a proportion. So we should be using the formula small p plus minus your z-deviate multiplied by square root of p times 1 minus p over n. That is the formula that we should be using. And among these choices, what represents that is choice D. 308 over 400, that's your small p, plus minus 1.96, the corresponding z-deviate for your 95% confidence level, multiplied by square root of pq. We have p, 308 over 400, and its complement, 92 over 400, divided by 400, which is n. So this is indeed your answer. Choice D. Next, what is the lower limit of the 99% confidence interval estimate of the parameter? So remember here, the z-deviate that you should be using is a 2.58. And everything else should still be the same inside the formula. Now, doing this properly inside your calculator should yield a 71.57%, which is letter A. The upper limit would, of course, be the positive formula. Should yield an 82.43%, or letter D. Now, on 10, we are asked how to interpret the 99% confidence intervals that we obtained from numbers 10 and 11. Again, components of a good interpretation, you should have the confidence level, the parameter being estimated, and the lower limit and upper limit. And in this case, the most representative of that is choice A. We are 99% confident that the proportion of women who use oral contraceptives is between this and that. We now go with situation C. So to determine the risk for cardiovascular disease, a researcher conducted a survey to estimate the mean LDL cholesterol level among women in Barangay Sitaw. He randomly sampled 25 women residents and found their mean LDL cholesterol level was 60, this should be micrograms. Yeah, micrograms per deciliter, with a standard deviation of 15 micrograms per deciliter. The OpenEpi output below presents a 99% confidence interval estimate of the parameter. This is your OpenEpi output. The first question is, what is the variable being estimated? Now, contrasting this from a previous question, what is the parameter being estimated? Of course, when you're being asked what the variable is, the parameter should not be inside the statement. And in this case, that is letter A. LDL cholesterol level of women in Barangay Sitaw. If you answer D, that's not the variable of interest. That is the parameter of interest. B is your population, so it's definitely not the answer. Okay, for number 12, what is the formula to be able to compute the interval estimate of the parameter? We do know that what we're estimating is a mean. Now, we only need to ask ourselves, is the population variance known or is it unknown? Going back to the problem, it says there that he sampled 25 residents and got a standard deviation of 15 micrograms per deciliter. If he got his standard deviation from the sample, then that just simply means that this is a case of population variance unknown, because he computed his SD from a sample. So the correct formula to use would be D, X bar, sample mean, positive, negative, the T deviate, multiplied by S sample standard deviation divided by square root of n, your sample size. Okay, now based on the output, what is the 99% confidence interval? This is merely being able to identify that whenever you have a population variance unknown problem, what you're going to use are t-test estimates or t-estimates. And in the output, the t-estimates are 51.6091 and 68.3909. So that should be your answer here. Okay, we have number 14. Interpret the 99% confidence interval that was obtained. Again, components of a good interpretation, your confidence level, your parameter being estimated, and your lower limit and your upper limit. The most representative of that is A. We are 99% confident that the mean LDL cholesterol level of women in Barangay Sitaw is between this and that. Now we jump to situation D. To determine the mean energy intake in kilocalories of children aged 9 to 12 years old, 60 school children were randomly chosen and their energy intake was measured using a 5-day food diary. Now, results show that the mean energy intake of the sample was 1,867.2 kilocalories with standard deviation of 565.8 kilocalories. The first question is, what is the parameter being estimated? Now, this seems like a giveaway because all of the other choices do not have any parameter. So you would immediately refer or answer choice B, mean energy intake of children aged 9 to 12 years old. Next, what is the lower limit of the 95% confidence interval estimate of the parameter? As you would notice, the pattern of the questions or the form of the questions across the situations are almost the same with one another. There's not much to ask in estimation. Here, our 95% confidence interval estimate is computed using the formula for a population variance unknown situation. If you would go back to the problem, you would notice that the standard deviation is actually computed from a sample, hence population variance unknown. Okay, if you do this properly, you should be able to arrive with 1,721.11. And the upper limit as 2013.29, which is letter D. Now we have situation E. A nutritionist wished to determine the status of breastfeeding in Barangay Kutitap. To achieve this, the nutritionist conducted a survey among women with infants in the barangay and found that 350 of the 500 respondents practiced breastfeeding. The OpenEpi output below presents the 90% confidence interval of the prevalence of breastfeeding in Barangay Kutitap. And this is the OpenEpi output. You already know from this that we're actually dealing with a proportion. Question is, what is the value of the point estimate of the parameter? If you would be looking at the output without computing for anything, that's just the one in the middle. So you have 70, C. Based on the OpenEpi output, what is the 90% confidence interval? Remember, whenever we're using OpenEpi, the option that we look at is WALD, which is normal approximation. Remember that we're using normal approximation for all our estimation situations. So the answer here would be letter C. So you just need to be able to recognize which one is WALD inside the output. Next, how do you interpret the 90% confidence interval that was obtained? Again, components of a good interpretation, confidence level, parameter being estimated, lower limit, and upper limit. Most representative of that is letter B. We are 90% confident that the proportion of breastfed infants in Barangay Kutitap is between this and that. Next, we have situation F. A researcher wants to determine the proportion of malnutrition among preschool children in a barangay. Suppose that a similar study was previously conducted and the proportion obtained was 30%. The desired precision and confidence level are set at 5% and 95% respectively. So here, it seems that we're already dealing with a sample size. The sample size for the study would be 323. So what is the formula for estimation of a proportion sample size calculation? That is z square, z deviate square, multiplied by p times 1 minus p, which is essentially the variance of a proportion, divided by your margin of error, which is d squared. And in order for you to answer number 21, you should be able to recognize the components of the formula inside the problem. Of course, our proportion is 30%. So p times 1 minus p is 0.3 times 0.7. Your z squared is 1.96 because we have a 95% confidence level. And then our margin of error is 0.05 squared. That should yield 323. Now, suppose that the researcher found out that there are only 1,570 preschool children in the barangay. What will be the minimum sample size requirement if this finite population is considered? We actually did not teach you anything on finite population correction, so this question is a bonus. Hooray. Alright. You have number 23. Given the same level of precision and confidence level, what will happen to the sample size if the hypothesized prevalence of malnutrition is lower than 30? So we have same other parameters, just the proportion being changed to a lower value. The answer should be the sample size requirement for the study will decrease. A. Remember, the highest yielding sample size of a value of a proportion is actually 0.5. When you have a proportion of 0.5, your variance is at maximum, which is 0.25. Now, as you veer away from 50%, 51, 52, 53, or 49, 48, 47, up to the extreme high values or the extreme low values, your variance decreases. It becomes less than 0.25. Now, because your variance is directly proportional with your sample size, if it decreases, then the sample size also decreases. Hence, the answer being A in this question. 24. Given the same hypothesized prevalence and confidence level, what will happen to the sample size if precision is lower than 5%? Your precision is inversely proportional with your sample size, formula-wise. So if precision becomes lower than 5%, then that means that sample size would increase. Sample size would increase. And we have the last one. Given the same hypothesized prevalence and margin of error, what will happen to the sample size if the confidence level is set at 99%? So we actually increase the confidence level. Your z-deviate is at the numerator, so it's directly proportional with your sample size. Now, your z-deviate is also directly proportional with the confidence level, such that for a 90, you have a 1.64, and then you have an increase at 95, which is 1.96, and another increase at 99, which is 2.58. So having the relationships all directly proportional to one another, you could say that if you have a confidence level set at 99%, the sample size requirement for the study should increase. Alright, so that is actually the last question for this lab exercise. I hope you have learned a thing or two, and I hope you can use this video as you go to your exam next Saturday. Good luck, everyone, and have a good day.